Hi, welcome to Multimedia Instruction Design video. My name is Tahir means Lahria. In this video, we will be applying two theories, the cognitive load theory and the cognitive theory of multimedia learning, adapted from the Cambridge Handbook of Multimedia Learning, 2nd edition, edited by Richard Mayer. Cognitive capacity is the capacity of a learner that can handle information presented in multimedia. So cognitive capacity is equal to extraneous processing plus essential processing and generative processing. So extraneous overload means when our cognitive capacity exhausts. It occurs when lesson contains extraneous material or is poorly designed. Essential overload is caused by the complexity of the material. It occurs when lesson is difficult, lesson is presented at fast pace, and the learner is unfamiliar with the material. Generative underutilization, learner has cognitive capacity available but does not engage in sufficient generative processing, occurs when learners lack motivation, does not exert effort. How we can manage three types of cognitive overload. Intrinsic load, we can manage intrinsic load. Extraneous load, we can minimize the extraneous load, and germane load, we can maximize germane load. So in this video we will be focusing how we can reduce extraneous load in multimedia instructional design. In multimedia instruction design, there are 5 principles that can help us to reduce extraneous processing. Number 1 is coherence principle. Number 2, signaling principle. Number 3 is redundancy principle. Number 4 is spatial contiguity principle. And number 5, temporal contiguity principle. We will be discussing 3 principles to reduce extraneous processing in this video. Redundancy principle describes using on-screen text with audio repeating the same text. So this principle states that people learn better when there is no redundancy in multimedia instruction design. So when you are narrating same on-screen text, that is redundancy. So we can reduce extraneous cognitive load by excluding narration or excluding on-screen text. Coherence principle means to avoid unnecessary graphics, words or sounds from the lesson. Those say less is more as compared to having too much irrelevant, unnecessary information on multimedia presentation. So in this case, if we have learning objectives, you will be able to connect and log into Blackboard Academic Suites. You will be able to enter your course in Blackboard Academic Suites. So these are relevant informations, and unnecessary graphics that can exhaust cognitive capacity of the learner. In this case, this lady sitting in front of the computer, that is unnecessary graphics. We can exclude those unnecessary information to reduce extraneous load in multimedia instruction design. The third principle we are discussing is spatial contiguity principle. Spatial contiguity principle states that people learn better when the labeling or words are close to their relevant structure or next to their relevant structure. So learner do not need to search those words if they are not close enough to the relevant or corresponding structure, so that can reduce extraneous load. So in this picture all the structures are labeled next to their relevant position. So aortic arch is labeled just next to it. Is very easy if it can exert extraneous load if we do not label next to this structure. And now we will apply these three principles to reduce extraneous load. I will be teaching simple human anatomy courses. So this very first presentation is simplistic form of blood circulation in human body. So in this presentation we can apply all three principles. So what is the relevant information? The relevant information in this presentation is simplistic presentation of blood circulation in our body in big picture. So what is our redundancy principle? So in redundancy principle, when I am describing that deoxygenated blood from the rest of the body enters into right atrium of the heart, then moves into right ventricle, then enters into lungs where carbon dioxide moves out and oxygen into the blood. Oxygenated blood from lungs enter into the left atrium, then into the left ventricle. From left ventricle blood moves into systemic circulation to reach rest of the body. So this text, on-screen text, is redundancy. So we can exclude this text to reduce extraneous cognitive load. Next you can see we have another irrelevant graphics right here. So we can exclude irrelevant graphics to reduce extraneous cognitive load. So this is application of coherence principle, right? And then we are using our spatial contiguity principle, that all the relevant structures, right atrium, right ventricle, left atrium, left ventricle, these words are direct representing the same structure. So in this video, this slide, we have three principles applied. So what we can do, we can exclude this unnecessary graphics applying coherence principle. We can exclude this on-screen text to apply redundancy principle to reduce our extraneous load, and then we are fine because all these informations are structure are labeled accordingly. So this right atrium is exactly where it should be. So now this picture, this multimedia PowerPoint slide is using all three principles. So now how we can use three principles simplistically teaching our naive learners. So deoxygenated blood from rest of the body enters into right atrium. From right atrium blood enters into right ventricle. From right ventricle of the heart blood moves into the lungs where carbon dioxide moves out, oxygen moves into the blood, and then this oxygenated blood enters into left atrium. From left atrium oxygenated blood moves and reach to the rest of the body. Okay, so this is very simplistic PowerPoint slide where we have used three principles to reduce cognitive load using 5 principles of reducing extraneous load can reduce cognitive load to match cognitive capacity of the learner. Hope it will help you to design your instruction design in your course